exciting episode of As the Sphere Rotates. Today we're going to be talking about spheres. A sphere is a solid where all points on its surface are at a constant distance from a fixed point. The constant distance is the radius, and the fixed point is the center of the sphere. A line segment joining 2 points on a sphere and passing through the center is called the diameter. If we take that radius and multiply it by 2, going through the center of the sphere, that's going to give us our diameter. Now, first thing we're going to do is talk about the surface area of a sphere. And in order to talk about the surface area of the sphere, what we're going to do is talk about Archimedes. Archimedes was born in Syracuse, Sicily. He was a Greek mathematician, engineer, and physicist. One of his greatest achievements was the discovery of how the volume of a sphere could be calculated by comparing it with a similar sized cylinder. But right now we're talking about the surface area. And what Archimedes believed was that the surface area of a sphere was equal to the curved surface area of a cylinder with the same radius. In addition, the height was equal to the diameter of the sphere. So if we take a look at this sphere, and we're going to create a radius, we're also going to take a look at the height of the cylinder. Now we know how to find the surface area of a cylinder, and that is 2 pi RH. All right, what do you suppose the height of this cylinder is? Well, if the distance from the center to the outside is 1 radius, and we turn it over so that it looks like this, you could kind of see that the height of the cylinder is going to be 2r. So we also know the curved surface area of the cylinder is 2 pi r times the height. Now in this case, the height is 2 pi r times 2r. The height we know is going to be 2r. So that means when we combine everything together, we're going to get 4 pi r squared. So the surface area of a sphere is 4 pi r squared. But what about the volume of a sphere? Let's take a look over here. We have a sphere. And what I want you to do is, let's suppose that we divide the surface area of a sphere into many tiny polygons. We're then going to join the corners of each of the polygons to the center of the sphere to make a pyramid. So what you see here in green is a pyramid. Now, the bases of the pyramids are very tiny polygons, but the height of each of those polygons is going to be equal to the radius of the sphere. You'll notice that the heights are pretty approximate there. So we do know that the volume of a pyramid, so we're going to use the volume of a pyramid here. We know that it's 1/3 times the base area times the height. Now we also know that the height is going to be referred to as the radius. Or simply r. But then what about the volume of the sphere? Well, we're going to take the sum of the base areas of all the pyramids. So all these bases here, we're going to pretend that they're covering the entire sphere. sweet. Looks like a Death Star. Anyway, so we're going to take these little surface areas over here and cover them all over so that we know that the base area is actually going to be equal to the surface area of the sphere. And then we're going to multiply that times the radius. Now, how do I find the surface area of the sphere? If you remember from the previous slide, we find the surface area as 4 pi r squared. So we're going to take 1/3 times 4 pi r squared times the radius again. So that's going to get us our total. 1/3 times 4 is 4/3 pi r to the third. That is how you find the volume of a sphere. Now, the real question I'm pretty sure you're thinking about is, Mr. Chavez, what does the net of a sphere look like? Well, the problem with nets, with spheres and their nets, is that paper can't really bend in two directions, and you kind of need it to do so in order to find, to create a sphere. You can't really do that. So the closest you can make is a net that looks something like this, where you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different figures cut out, and the measurements are going to depend on what you are looking for in terms of the size of your sphere. That's pretty much all we have to go on. Later we're going to go over some examples involving spheres and their surface area and volume.